right, hi everyone, it's Mrs. H. Today we're going to talk about complex numbers, which is section 6-8. This is a very logical next step from talking about imaginary numbers, so hopefully nothing is too brand new here, but it also ties back a lot to everything we did with radicals. So again, just kind of taking a bunch of skills that we know already and throwing them all together. All right, so first, complex numbers. What the heck is a complex number? Well, these are numbers in the form a plus bi. A and b are going to be real numbers, and then I, is our square root of -1. That's our imaginary number. The number here, a, is our real part of our complex numbers. And then b, the coefficient in front of I, that's the imaginary part of our complex number. All right, now a few things about these. So we have equality here. We can set two complex numbers equal to each other, and this is true. So here I have a plus bi and c plus di. Our real part needs to be the same, and our imaginary part needs to also be the same. We can essentially treat our imaginary number I as if it was a variable here, and we can add together, and here we're going to add together the real parts. So we can have a plus c, and I'll kind of throw that in parentheses there, and then we can add together our imaginary parts, and I'm really just treating my I as if it were a variable. How many i's do I have? Well, I have b plus d of them. This way, we now can just combine. We can add, we can subtract, we can compare imaginary numbers, complex numbers. And so there's a whole bunch of stuff that we can do. Now, for our product of our complex numbers, we're going to basically FOIL out, and then we're going to use what we know about our complex numbers. So we're going to start with a times c, and then we're going to multiply outside inside. And when we do outside inside, we're going to both have an I term. So we'll have a, d, I, and then we'll have BCI, which again are going to be like terms here. And then I generally, when I'm doing this, will do it out, just because I know I'll make mistakes otherwise. But when I multiply, I get b times d times I squared. But from that last section, when we talked about I and I squared and I cubed and I to the fourth and all of that, we actually know what I squared is. So I squared is -1, which is going to make this become minus BD. That means that our AC and BD will then also be like terms. AC and BD will make our real part of our answer, and then the blue in the middle here, our ADI and our BCI, that will make up our imaginary part. All right, let's do a few of these, and then we'll kind of conclude with a Venn diagram talking about how this is all related. All right, so starting out with just some simplifying, I just wanted to highlight a few things to be careful of. You don't necessarily need to write everything out, do all your steps out on everything. It's a good idea in the beginning. Here, I have my real parts, my 3 and my 4. I have my imaginary parts, my 6 and my 2i. I'm just adding everything together, and so I add my like terms together. There we go. For a question like number 2, I highlighted this one to include simply because you really need to be careful with minus. It's going to be -4 and then minus -2i. This one I probably would rewrite just so I don't make any dumb mistakes. 3 minus 4, and then 6i and 2i is going to give me 8i. There we go. On question number 3, again, I really just kind of like to write it all out. So I have 12. I'm going to have minus 6i. I'm going to have plus 24i. And then I'm going to have minus 12i squared. And then at this point, I'll cross off my I squared and I'll change that to a plus. That I squared is really -1, which is going to make my minus a plus. And now I'll go through and kind of do everything else. I like this rather than just following a general rule up there, just because, we have all sorts of positives and negatives. And so I don't want to just kind of make a general rule that it's always minus or something like that. All right, I have 12 and 12. That's going to give me 24. I have minus 6i and plus 24i, so that's going to give me my plus 18i in the middle. All right, let's actually jump down to number 8 next before we talk about number 6. Number 8, we're going to distribute. And again, I'm just going to be extra careful when I'm distributing. I'm going to start out. I'll write everything down. I'm going to multiply outside. Well, this is fine. I know how to multiply this. I have minus, and then I have 3 and I outside my radical and root 6 under. Here, I'm going to have plus 3i root 6. Oh, big surprise. Those undo each other. And then I'm going to write out what I have here. I have minus, because it's plus times minus. I times I on the outside will be I squared. Root 6 times root 6 is going to be 6. Now, let's see what happens. Well, first of all, my plus 3i root 6 and my minus cancel each other out. We knew this because these two are conjugates. And then what else happened? Minus I squared times 6. The I squared will make it plus, and I get 9 plus 6, which is going to give me just 15 as an answer. We're going to use that and use what we know about conjugates to also rationalize our imaginary numbers. So like with square roots, I do not want an imaginary number in my denominator. That means here for number 6, we are going to multiply by the conjugate of the denominator. So I'm going to multiply by 4 plus 2i and 4 plus 2i. Now, I could have actually factored out a 2 in the bottom. And hold on. Let's do that because I think that's what they were getting at here. We'll rationalize in a minute. I can factor a GCF from the top. I'm left with 1 plus 2i. I can factor a GCF from the bottom. That's a 2. And I'm left with a 1 minus 2i. Oh, nope. Didn't get me anywhere because I can't cancel anything. This is just like with our parentheses where I need to have the exact same thing. Okay, so never mind. I was on the right track the first time. I'm not even going to pull out that GCF until after. All right, so I'm going to multiply by the conjugate of the denominator. So I have 4 plus 2i. Up on the top, I'm going to have to go ahead and multiply that all out. And then on the bottom, I do have to kind of multiply out, except I know some of what's going to happen. Let's see on top. I get 12 plus 6i plus 24i plus 12i squared. On the bottom, I have 16. Well, I'm not even going to write down my plus 8i and my minus 8i because those are going to cancel, and I'm left with minus 4i squared. Now I can do a little bit before I go ahead and simplify. I squared is going to make this a minus 12, and this I squared is going to make this a plus 4. That means I have 12 minus 12. That's going to be gone. So up in my numerator, I just have 6i and 24i, which is going to give me 30i. Down in the denominator, I'm going to have 16 plus 4, which is going to give me 20. Now I can simplify this, and I get 3i over 2, or 3/2 I, either way. All right, we're going to use that for number 11 as well. Number 11, I want to find the reciprocal. So what they're saying is this is like a fraction over 1. So what do I want to do? I want to flip it over. So I'm going to have 1 over. All right, now I want to simplify this by rationalizing. So I'm going to multiply the top and the bottom by the conjugate of the bottom. That's going to be -5 plus I root 2. And we know that this is going to get rid of not only the i's, but also the radicals, because this is exactly what we did for radicals. I'm happy that there's a 1 up on the top, because I can just multiply out up on top. and have my original thing left over. So I have I root 2 like that. Down on the bottom, I'm going to have to FOIL. Let's see, -5 times -5. Outside, inside are going to cancel. That's the whole point. That's why we chose the conjugates. And then I'm going to write out what we have. We have minus I squared. Root 2 times root 2 is going to be 2. All right, let's see. I squared means that this is going to be plus. So I have -5 plus I root 2 up on the top. Down on the bottom, I have 27. That is it. That's all we can do. A couple more just to emphasize a few more points on the second page here. All right, let's see. We have this whole thing squared. So I need to make sure I multiply this all out. I'm going to get 16 minus 20 minus 20 is going to give me minus 40i. And then I'm going to have plus 25i squared. But wait, what is I squared? It's just going to make this a negative. 16 minus 25, well, that's going to give me -9. And then I have minus 40i. Technically, -40i minus 9 is also correct, but we like to write our real part first. Now, question 16. Again, we have some radicals in here. I probably would not do this out as is. I'm going to take out that I first. So I'm going to rewrite my problem, and I'm going to write this as root 2 minus I root 5. And then root 2 plus I root 5. Now, we do end up having conjugates here, but the pulling out that I first is what I really wanted to highlight. And I'm going to go carefully bit by bit. Let's see. Root 2 times root 2. We know that from earlier in the chapter. That's just 2. When I do plus I root 10 minus I root 10, those undo each other. So I'm not even going to write them down. And then last times last, outside my radicals, I have minus I squared. My radicals themselves, I have root 5 times root 5. So that's just going to give me 5. All right, well, what's I squared? I squared is -1, so that turns this into plus. How nice. My answer here is just 7. All right, and 2 more that I think are worth doing. Number 20. Number 20 is actually pretty easy if you think about just kind of filling the basket. But what I wanted to show you on number 20 is that even with our radicals, I don't think we actually did this with radicals, but what I could think about is this original problem as a complex number. What is that complex number on the bottom? Well, my real part is just 0. And so when I want to get my conjugate, what am I going to do? I'm going to multiply by 0 plus 2i. Now, this is not actually what you have to do in practice, but I'm going to show you this way, and then I'll show you the second way. All right, so let's see. Up on the top, I get 16i. Down on the bottom, well, sure, I guess I could FOIL these out. I don't think it's worth it because the zeros don't actually really matter. And so what do I get? I get -2 times 2 is going to give me -4, and I times I is going to give me I squared. All right, I squared, well, what is that? It's really a plus 4. Now I have 16i over 4. I can simplify this further because 4 goes into 4 once and into 16 4 times. My final answer here is 4i. This is great. However, this is way too long, but I just wanted to kind of show that really all along you can use the conjugate every single time. Let's go back to our original problem though. My problem in this question is really just my I. I want to get rid of that I. I know what I squared is, and so I'm going to just multiply top and bottom by I. That's going to give me 8i over -2i squared. Again, I squared is positive. I get 8i over 2. And again, I can simplify and I can get 4i. I think this way on the bottom is a little bit quicker. However, if you just want a general rule that you can follow, you can always multiply by the conjugate. All right, one more question, and that's number 23 here. So let's just do out kind of a more complicated one where we need to multiply and get rid of our not only radicals but also our imaginary numbers down on the bottom here. I'm going to multiply by the conjugate, -3 plus I root 5. Remember, the only thing that changes is that sign in the middle. All right, if I'm multiplying by that on the bottom, I have to multiply by that on the top because you don't have an equal sign, so you can't change any meanings here. I'll throw parentheses in everywhere so that I don't make any silly mistakes with my multiplying, and let's see what we get. In the numerator, I'm going to get 9. I'm going to get -3I root 5. I'm going to get -3I root 5. So I'm going to get -6I root 5. And then I'm going to have plus I squared times 5. I'll deal with that in my next step. Down on the bottom, I'm going to have 9. I'm going to have -3I root 5. And then here I'm going to have plus 3I root 5. Those cancel each other out. Good, that was the whole point. And then I'm left with I squared times 5. All right, next step. Let's simplify even more. I squared is negative. I squared is negative, so it changes those signs. 9 minus 5 is going to give me 4, and then I have -6I root 5. Down on the bottom, 9 plus 5 is going to give me 14. Well, what's going on here is this is not actually the final answer. What you need to do at this step is pull out a GCF up on the top. When I pull out a GCF in the numerator, that is going to be 2, and I'm left with 2 minus 3I root 5 all over 14. We're way back, way back. I have 2 things multiplied on the top. I have 1 on the bottom, so now I can cross anything off that I see that's the same on the top and the bottom. In this case, it's 2. 2 goes into 2 once, into 14 7 times. And so my final answer here is my entire numerator, which was in parentheses. You can leave it in parentheses if you want, all over 7. So a lot of different things kind of going on in these problems. The rest that we did not do, the answers are going to be attached. I will post this with, I'll post a blank copy along with the one that I worked out. And our last thing I want to just draw is a Venn diagram of our number system. All right, so what actually is happening, this is really cool, is we have our giant Venn diagram, and we, up until now, have always talked about real numbers. Well, real numbers are actually a subset of complex numbers. Because remember, what are complex numbers? We said it's A plus BI. Well, real numbers are a piece of that, and real numbers are just when we have only RA. So real numbers here are when B equals 0. And then we have a whole ton. We drew this Venn diagram earlier in the year. We have real numbers. What's inside real numbers? We have rational. We have natural numbers. We have whole numbers. We have that whole Venn diagram from earlier. On the other side here, I guess I shouldn't have drawn a line. Let me kind of make this into a bubble inside. Because what else do we have is we also have pure imaginary numbers. So what is that? That's when A is equal to 0. And that's when we just have a number like 3i or -21i. Outside of both of these are our complex numbers. So like real numbers here, right? We have, I don't know, the square root of 2. That's a real number. That's a real only number. Pure imaginary, we just wrote a few down. Outside of those two, but still in complex numbers, would be like the ones that we've just been dealing with, our 3 plus 2i, when we have a real part and an imaginary part. Obviously, size here is not accurate, But I kind of like thinking about this now because unbeknownst to you, your whole math career, you've been working with complex numbers, just that didn't have the imaginary part. All right, we will practice some of this, especially after vacation. Thanks, everybody. Good luck with the bookwork.